Naomi and Greg. This video is on graphing linear equations. Specifically in this video, I'm going to focus on linear equations that aren't in standard form or y equals mx plus b form. They're just linear equations. They haven't been put into any particular form. Now, one way to graph them would be to put them in standard form and then graph, or to put them in y equals mx plus b form and then graph. But you can also just find points that make them true. So this first equation we're going to look at is x minus 1 equals y. If you flipped it around, made it y equals x minus 1, then you'd have it in y equals mx plus b form. But I just wanted to focus on the idea, so y in this equation is by itself on one side of this equal symbol, so it's going to be easier to pick values for x and find values for y. So let's see, x values. I'll just use easy ones, not enter. 0, 1, 2, 3, those aren't so bad. And then I just take those values and I replace the x in the equation with those values. So for example, if x was 0, 0 minus 1 is negative 1, so y would be negative 1. Or if x was 1, 1 minus 1 is 0, so y would be 0. Or let's see, if x was 2, 2 minus 1 is 1, so y would be 1. Or if x was 3, 3 minus 1 is 2, so y would be 2. So you can see we get points just by putting in whatever value we like for one variable. We could pick values for y, but we'd be left with something like x minus 1 equals 5, and then we'd have to solve that equation rather than just subtracting values there. So let's undo that. So these values on the graph, when we go over here to graph them, let's see, 0, negative 1, that's over 0, down 1, so it's right there on the graph. 1, 0 is going to be right 1 and up 0, right there on the graph. 2, 1 is going to be right 2 and up 1, so that's over 2, up 1, right there on the graph. And then 3, 2, that's right 3, up 2, should be right there on the graph. And by doing a few points, you can really see that your points all line up, and if they don't, you know you've made a mistake. So you really only need 2 points to graph, but by doing extra ones, you just use them as a check. If you were in my math lab, you'd graph using 2, and then you check and make sure those other ones are on the graph. So drawing the line here, looks like it will be, want to get it right, okay, right there. This line has a slope of 1, up 1 over 1, and it has a y-intercept of 0, negative 1 there. And this is the graph of this particular equation. So let me go on, I'll do a second one, and we'll work it the same way. So this one, let's see. For this particular equation, I have x isolated on one side of the equal symbol instead of having y isolated. It's kind of non-standard, but you'll see it every now and then. And so for this particular one, I'd rather pick values for the y and use those values to find x instead of going the other way. So last time we did the other way, we picked values for x to find y. Here we'll pick values for y to find x. Either way works. So 0, 1, 2, 3. I'm just picking easy values. Let's see. If I put in 0 here, I would have 2 times 0 plus 4. That's 0 plus 4, so that's 4. If I put in 1, I'd have 2 times 1 plus 4. That's 2 plus 4. That's 6. If I put in 2, I'd have 2 times 2 plus 4, that's 4 plus 4, that's 8. And then if I put in 3 for my y value, I would have 2 times 3, that's 6, plus 4, that's 10. So here are some points. I just go over to the grid and graph them. 4, 0, right there. 6, 1, right there. I'm going to go ahead and draw the graph through those. And you can see that this graph also goes through 8, 2, and it also goes through 10,